we're going to do 5.2, which we finished. Let me go backwards a second to the previous one for a quick second, because I want to make sure that we left off where we left off at. Scroll down, go back up. All right, so we left off at that page. That page was, you got some stretch or compress, and you got some shifting left, right, and up, down. That was where we left off with last time, right? Yeah, so that was part of what you would have seen in the homework. So I want to kind of go to the next part of this, which will be log functions. So let me say something about log functions for a second. We did those two, right? Didn't we do these? We did. This is going to be, we talked about whether it's going to be increasing or decreasing. This was a decreasing. This one's going to shift to the right. Excuse me, not to the right. It's going to shift. Not to the left. Going to shift. Up to. This one's going to shift. To the right. How many? 1. This has a stretch factor of 3. Going to shift to the 2. And then. Okay, so we did all of that last time. So now we're going to jump right into something called logarithms. Now, what kind of equations were those? Starts with an E. They were exponential. Well, there is something called a log equation or logarithmic equation, which is the inverse of those. So remember, in the previous sections, we talked about all these different equations, and we talked about some have inverses. Well, these equations have inverses as well. So the next section that we're going to talk about is logarithms, which are the inverses of exponential equations. So if I give you an exponential equation and say find the log of it, you're finding the inverse of it. Alrighty? So let me give you some examples of what I mean. I'm going to start with the first one, which is log functions, then we'll talk about common. So here's the next slide. Now, if you try to read that slide, it probably don't make no kind of sense what it says up there. I mean, I know you could read it, but the question is, does it make sense? Well, let me give it to you like this. So I'm going to rewrite what's on the screen in a manner of which I want you to be able to understand it. So here is y equals 3 to the x power. What kind of function is that? Y. How do you know that? Because the x is the exponent, right? And what if I said I need you to go find the inverse of that equation? So here's how you find the inverse. Now, step 1, switch the x and the y. That's your step 1. X and the y. So in the place of the y, I'm going to put here, and then I'm going to put the y up there. Step 2, do something I created called the circle method. So this is step 2. Circle method. I says do circle method. Well, you might, what is the circle method? All right, so here's the circle method. I'm just going to rewrite the equation for a quick second. Circle method says I am going to put a point here underneath the 3. That's called your base number. I'm going to draw an arrow to this x and an arrow to the y. And I've created what I call a circle. That may not look like a full circle, but you might want to call it the arrow method. Whatever you call it is fine.
Can you explain it one more time? You draw
You start on the side of the equal sign wherever the exponent is. Is the exponent on the right side of the equal sign? Mm-hmm. So then you got to start on the right side, and you always put a dot underneath the base, not the exponent underneath the base number. I just call it a dot, just a little darker. This tells me where to start. This is just going to tell me where to start. And I'll show you in a minute why I put a dot there. So here is step 3. Rewrite in log form using the circle or the arrows, whatever you want to call it, using the circle method. Alrighty, so here is how a log equation looks. Alrighty, I need you to fill in these boxes. Well, that's what the circle tells you to do. Wherever the dot is, that's where we start. So we start with what number?
3.
That goes in which box? First box. What goes in the second box? Is where the arrow points. What goes in the third box? Done. You have now written the inverse of that equation. So I'm just going to rewrite it with the y over here on this side. Can I rewrite this like this? What did I just do? I just switched with the y in this over there. Because I like to see the y first, that's all.
So what was that?
But they're the
first
same
one be right
thing.
too?
Say it again.
The first one, that'll be right too?
Both of these are right. I just like seeing the y first. I like seeing y equals. But it's not wrong. It's perfectly right. All right, how do you read this? So y equals 3 to the x power. The inverse is y equals log base 3 of x. That's how you read that. Y equals log base 3 of x. That's how that's supposed to be read. You've just found the inverse of y equals 3 to the x power. You okay so far? You got to use the circle method. So, for example, when I look at your test paper when you have a test, I'm looking to see that you drew the circle or the arrows. Whichever one you needed to make sure you put it in the right form. You ready? Okay, you okay with this? All right, so then your turn. Y equals 5 to the x power. Do the inverse for me. You can probably see it without even doing all the work, can you? Can you see the pattern without doing the work? Yeah. What you think the answer down here is going to be when we get to the answer? Y equals? I agree. Log base 5 of x, that's right. So far that looks okay. You okay with that? All right, what if I change it a little bit now, and I give you this, and I say, I want you to write this in log form. Is it in exponent form? Does it have an exponent? It's just all numbers and no letters. So I have an exponential equation. It has no letters, but I want you to write it in log form.
So 9 equals.
So wait. So we got to do, now, do you have X's and Y's? So you can't switch nothing. So jump right to step 2. So let's do circle method. Now, where's the exponent on? What side is the exponent on? Put a big old dot over here and draw your circle like that. The only time you switch X and Y's is when they got X and Y's. If they don't have no X and Y, you can't do step 1. You go straight to step 2. Alrighty, so I need my boxes. So I need log, I need a box here at the bottom, a box here, and a box here. Alright, what goes in the first box? Wait, I heard a question.
You don't start at the 9?
We start wherever the dot is. That's always your starting point. And I purposely wrote it that way because you see how I wrote this one? And look at where the dot was. It doesn't matter as long as you start wherever the exponent is. The dot got to go on the side where the exponent is. So if I put my exponent on the left, your dot should start on the left. If I put my exponent on the right, your dot should start on the right. Now, all the circle method does is tell you what to put in each box. So what's going to go in the first box?
3.
Second box? Last box.
2.
Oh shoot! I did 2.
You just follow the arrows to determine what goes in the boxes. That's it. So here's my original equation. 3 to the 2 power equals 9. My log form of that, the inverse is log base 3 of 9 equals 2. You okay with that? All right, so let me do one. Let me do another one. I want to make sure you got it, so I'm going to do another one. So here is 4 to the 2 power equals 16. Can you rewrite that in inverse form and log form for me?
Yes.
Circle method. So I need a dot. All right, write your word log. What goes in the first box, second box, and third box? 4.
16.
You've just converted it from exponent form to log form. You okay? Now, if you go to the tutoring center and say, can you show me how to do the circle method? They're not gonna know what you're talking about because I created that. Okay, ready? All right, what if I don't put no letters in it? No, excuse me, no numbers in it. I meant all letters. So what if I have in the homework, it might say T to the V power equals W. The only time you switch it is when it's got X's and Y's. Does it have X and Y? No, so we're gonna jump straight to the Can you write the log form of that? Where did I put my dot? Under the T. Why did I put it on that side? Because that's what exponents were. So now I need my box. I need a box here, and I need a box here. All right, what goes in the first box? Second box? Last box? Done.
And why you don't V? I must mistake that.
Thank you. Yeah. Monique, was there another question you were asking?
Cause you missed the step. Step 1, you're supposed to switch.
You only switch when? Only if they have X and Y. Only if it's an XY problem. Only if it's got Y equal 3X or Y equal 5 to the X or Y equal, it's got to have X and Y. That's the only time you switch. Otherwise, all the other times you skip step 1. Only time you switch is when it's both X and a Y in it. You okay? That's what that slide says. I know y'all like, that slide don't look like it said nothing like what you got on the board. That's not how it's being taught, but it's confusing to teach it the way you'll see on the normal slides. All right, you okay? Now, does it matter if I write this? I'm doing this problem right here again. Does it matter if I write this 9 equals 3 to the 2 power? Well, let's see if anything changes. Dot.
Yeah.
I'm just checking, just making sure. So I've got log, box. Oh, what goes in the first box?
3.
Second box.
No.
Last box. Did anything change?
No.
No. It's just how your circle gonna go this way or it's gonna go this way. Either way, you start where the dot is and follow the arrows. I'm listening. Go ahead.
The circle method, no.
I like it. I like it.
Patent that.
I like it.
Call this the Harris method.
There you go.
Feel me?
Make an app so I can charge a nickel for each one to get into the app, right?
I support it. I'm invested. I'm invested. I'm invested like the Shark Tank.
Okay. All righty. So let's see. So now you know how to convert from exponential to what form? To log form. And now we want you to see what it looks like in graph form. So type the first one that we started with in Desmos for me, please. So let's go to Desmos. Where is mine? Alrighty, so go to Desmos. Let me delete this. All right, so we have y equals, what did I say, 3 to the x power. All right, there's my curve. And the key with this is just so you can get a chance to look and see what the log equation looks like. What was the log equation? Y equals log. All right, let me show you how to put a number way down. See this number right here? See how we put a 3 right there? You gotta know how to put that number in there. So if you click on ABC, click on ABC. All right, I got to call you back.
I'm confused. What we doing?
We get ready to type the inverse in. We type this in first, and we get ready to type the inverse so you can see what both curves look like. So I'm gonna do log base 3. How do I make that little bitty 3 pop at the bottom? Click on ABC and see this little bitty button right here? It's got an A with a little teeny weeny B hanging. Click that one and it'll drag, not drag, but it'll pop it down to the bottom. A with the little bitty B. Did you find it? Now, once you put it there, you got a cursor back up. Because if you don't, it's going to keep putting everything at the bottom. See? If you don't put the cursor back up, so backspace all of that out. Now take your cursor and go back up so that you're on the same level with the LOG. Now put in your X. And now have a different curve. See the other curve? So the black curve is the inverse. The purple curve is the original equation.
So we don't put the equal y?
Oh, wait, what was the question again?
So we don't put the equal y, we just leave it log base 3x, we don't do equals y?
Well, we already have y equals in there.
Okay, all right, that's it.
I didn't know if you wanted me to put it in there in a different location. No? Okay.
How did you get the 3 again?
Oh, so the 3, go back to your keyboard right here. Open your keyboard up. Click ABC. And this little doohickey button right here. Yeah. It causes it, let's see how it made it drop down. It puts the cursor down low. And then you put your number in there and then put your cursor back up. So we don't want nothing there, so I'm going to delete that back out so it goes back to what we wanted. All right, you ready? So we're good? So you've got the original exponential function and you have its inverse. Ready? So you know what the graph of it looks like. That's all. So when you type in any equation that has log in it, y equals log of x, you see what the curve looks like. That's what the curve looks like. Let me change something and see what happens. I'm going to change this to y equals log base 9. Cursor back up of x. I want y'all to see what happens as we change this. Log base 8. I'm just changing it so I can see if you see what happens with the curve. Log base 7 of x. Whoops. That's y equals base 7 of x. Let's see if we can see the graph. You can't see it because I got my y-axis wrong. All right, change my y-axis to, let's make it 8. And I want to make this one -1. All right, I'm going to have to make it even smaller so you can see it. Hold on, I got to make this even smaller. All righty, so let's make this 3 or 2. Can you guys see it? As I made the number smaller, as I made my base smaller, look at what happened to the curve. You see it? So just notice as we change these numbers, you can see that the curve, it's a similar curve. You just got a little bit higher and a little bit higher and a little bit higher. So then if I come down here and put in underneath there, okay, hold on, I'm not looking at my keyboard. Y equals log, and I'm going to put in a 2. Not that. Click on my ABC, put a 2 in here, go back up. Aha, look what happened. So do you see that the smaller this number gets, the higher the curve is? That's what I wanted you to see. So you could see what you should expect the curve to look like. Alrighty, so that was that part. All right, let's go back and see. So now let's talk about the characteristics. Now here, for the log curve, it always has an x-intercept at 1, 0. Does it ever touch the y-axis? Never. Remember when we looked at the other one, it did touch the y-axis? The log curve doesn't touch the y-axis at all. The domain is every number in the world greater than 0, and the range is all the real numbers in the world. So again, let me go back to the graph again so you can see it again. Let's delete. I'm going to delete all these extra ones. You know, delete, and delete. Alrighty. So let me put in y equals 10 to the x power. Oops, 10 raised to the x power. All right. And they shouldn't be the same color. Alrighty, there we go. All right, so as you can see, and let me hit the home button so it'll put it back. All right, so you can now see for both of these graphs. Now, which one is the exponential one? Blue or red? Blue is exponential, red is log. Now, when we were talking about the exponential curves, which is blue, it does cross the y-axis. Can you see it crosses it right here? It's never going to touch which one, even though it looks like it's touching it. It's never, this blue curve is not touching it. I know y'all like, yes it is. No, it's not. It is not touching it. I know it said it, and if we make the graph so you can see it a little bit smaller, it is not touching it, even though it looks like it's touching it. The log curve is never supposed to touch the y-axis, but it looks like it's touching it. It's not touching it. Okay? So when we go back and look at the characteristics, the log curve will always cross the x-axis, but never touch the y. The exponential curve will always cross the x-axis, the y-axis, but never touch the x. I just want you to see that the difference between the two. You okay?
Can you say it again, the difference?
The exponential curve, which is the blue curve, will always cross or touch the y-axis, but it can never touch the x-axis. The exponential curve can never touch the x-axis. The log curve crosses the x-axis, but can never touch the y. Even if it look like it is, it ain't. All right, so let's go back to the PowerPoint real quick here. So we already graphed them so you can see what they look like. Now that you know what they look like, let's talk about the common log. The only reason we call this a common log is because it's base 10. And base 10 is you don't put a base at all. So for example, notice here, did I have log base 3? Yep, here I had log base 4. Here I have log base t. When there's no number, it's assumed base 10. So if I had log of x equals y, what's the base? 10. Are we ever going to write it? Never. I'm going to assume that if you don't see a number, right here hanging down low by this G, it's 10. But you're never going to write it. It's like, putting a 1 in front of a variable. You're never going to put that number 10 there, ever, ever, ever. Every other number you'll put, 3, 5, 7, 9, 18, TV, but you're never going to put 10, ever. That's called the common log, because it's just denoted by y equals log of x. You can write it either way. Both of these mean the same thing. Log of x equals y and y equals log of x. They both are the same thing. The base is 10. All right. So then now that you've gotten that part, this is called the common log. Now we're going to talk about the natural log. So let me put this up so you can see. Here's the next slide, natural logs. Now, on your calculator, you should have an LOG button and an LN button. Do you see it? On your handheld calculator, do you have a log button and a natural log? One is LOG, one is LN. Looks like an IN, but it's LN. Do you see it? Okay. Whenever you see the LN, it's called natural log. I know it looks strange, like why is natural log if it's the LN instead of NL? But that's what we call it. It's natural log, and whenever you see it, it's written like this. So if I say find the natural log of something, it's y equals natural log of x, or of a number. It could be of 2, of 15, but that's what you're going to see when you see the equation written. It's the same thing as log base E of x, but you're never going to write it like this. Unless we're doing some sort of circle method. When you put it in the calculator, you're not going to put it in the calculator like this. You're always going to write it like this. So whenever you see the LN, it always means there's an E somewhere in that. So let me show you how we came up with that. So let's do that now. Here's an exponential equation. Y equals e to the x power. Is that an exponential function?
Yeah.
How do you know? Okay, did we talk about what the letter E means?
Yeah, like
Yeah.
G1.
Yeah, Yes, is E a number or a variable?
A number.
It's a number, so we actually raising that 2 point something something power to the x power. Now, do I have an x and a y?
Yeah.
Should I switch them?
Yeah.
Yes, we should. So I'm gonna switch x and y. Then I'm gonna do my circle method. Where I start, wherever the side of the exponent is, do my circle. There we go. Now, instead of putting L-O-G, what am I gonna put? L-N. All right, what goes in the first box?
X.
Well, look at the circle.
E.
E. Second box.
X.
Last box.
Y.
Now, when you do your final answer, it's like base 10. You're never gonna write that E like that, ever. It just showed me how I could do it with the circle method, so let me push this board up some more so you can see. So here's my final answer. My final answer is y equals natural log of x. Do not write that little bitty E that I put there just for the circle method purposes. You need the E there so you'll see how to do the circle method. But your final answer should look like this. This is the y equals the natural log of x.
Parentheses?
They put them in the homework, but it just means of x. It don't mean times. I don't usually put them because I don't want you to think that means times. This is of x. Natural log of x. Do not write the little bitty E that you see right there. Do not write it.
So the way you write it is L-N and then a space and then the X.
That's the way I write it in the homework. You're going to probably see it with parentheses around it. I don't like the parentheses because it makes you think it's Ln times x. So I don't like having the parentheses there. I like putting a space in between them. Alrighty, so when you graph it, you just literally type y equals Ln of x. So if we go to Desmos, let's actually put that in, delete these, delete y equals natural log of x, and I put a space. So there's the curve, there it is. So it just wants you to see what that one looks like as well. Y equals natural log, I just literally typed the letter N, the letter L, put a space and an X. Could you put parentheses around it? Sure. Will it change anything?
Will that also be, 1,0?
Well, you mean, yeah, where is it? This one right here, that point right there. So it's crossing the x-axis at 1,0. So it crosses the x-axis but never touches the y. Questions?
I have a question.
Yes.
Cause you said don't put the E, but if the E was a number, we could put the number?
Natural logs will never have a number there. Never, ever, ever, ever. It won't ever have a letter there, a number there, nothing will be there, ever, ever. It will always be E that's invisible, but never anything else. However, the LOG can have all kind of numbers there.
So you're saying it'll only look like Y equals the EX. And you said won't ever have any numbers.
There will never be numbers here, ever. The only thing that will ever be there was an invisible E. You cannot do it like LOG and put all kind of numbers. You will only ever have an E here. Never, ever. Anything but E. And it will always be invisible. Alrighty, so we got that part of the graph done. So now let's talk about some properties associated with these logarithms. So with these properties that you see on the board, these are like basic rules of mathematics associated with logarithms. So I'm just going to kind of give you an example of each one so you can see, because in the homework, they're going to give you examples of them and want you to figure out what the answer is going to be. So I'm going to do one for each one so you can see it. So bullet number 1 says if you have log base B of B is equal to the number 1. All right, what does that really mean in real mathematical terms? I'm gonna erase these B's and put numbers. There's a 3 and there's a 3. So, when you have log base 3 of 3, the answer is 1. If you have log base 5 of 5, the answer is 1. If you have log base 6 of 6, the answer is 1. If you have log base 7 of 7, the answer is 1. So, what did we just say? Whenever these two numbers are the same, what's the answer?
1.
That's it. Can you check it and make sure it's right? Here's how you check it and make sure this is right. We're going to do the circle method to check it. You're like, we can check it with the circle method? Absolutely. All righty. Start wherever the number that's hanging by the G is. What number is hanging by the down below with the G?
3.
That 3. So you always put your dot there. Here. Here. What form is it in right now? What form is the
Circle method. Log.
no, I know we're getting ready to do the circle method, but what form is the equation in?
Log.
It's in log form. I'm going to turn it into exponential so I can check it. So I'm going to use my circle method to turn it back into an exponent so I can check it. So here's my check. All right, so box. I need a box here and I need a box here. So we're just checking it to see if we got it right. All right, what goes in the first box?
3.
Second box? Third box? Is that right? Is that statement true? Is 3 to the 1 power equal to 3?
Oh, yeah.
Now you know you got it right. So you can check all of these with the circle method to put it back in a proper form that makes sense to you. So if you can rewrite it back in exponential form and it makes sense, then you did it properly. Question? Alrighty, here is bullet number 2. All right, bullet number 2 says we have log base B of 1 equals 0. I'm going to put a number in the place of that B. So, whatever number I put here, let's go with 3 again. All right, so log base 3 of 1 equals 0. Can I check it? This says whenever the base is whatever number it is, and you have a 1 here, the answer is always 0. It don't matter if it's log base 6 of 1, log base 2 of 1, log base 17 of 1. If that's a number and a 1 here, answer is always 0. Well, let's check it and see. All right, put a dot here. Draw it 2 there. All right, here's I'm going back to my exponent form again. 3 to the what? 3 to the 0 power. Anything to the 0 power is how much?
1.
Did that check out right? Yes, it did. All we did was check it. This is the checking part of it. We were just checking it. So if I say log base 5 of 1, what's the answer again?
Oh, 5.
Log base 5 of 1.
0.
0. Okay. Just checking. All right. Next bullet. This is bullet number 2. It says, what if I have log base B of B to the X power, and it says equal to X. All right, so let me put some numbers in here so you can see if this makes sense. All right, log base 3 of 3 to the 2 power is equal to 2. That's what that says. If these two numbers are the same, the answer is the exponent. If these two numbers are the same, the answer is the exponent.
You circle back with that.
Check it. All right, let's check it. All right, come on, let's check it. All right, ready? Circle, dot goes here to here. And I need another better color marker because my black is going. I apologize, guys, because I changed bags since they gave me my laptop back and forgot to put all my markers back in my bag. So I'm gonna have to go get a marker if I can't find a marker here. Hold on. I can't believe I really don't have a whole bunch of extra markers. Let me try this one and see if this one works. Alrighty, so here to here to here. Now, here's my question that I need to ask you. Let's see if I've got this right. Make sure I ask you right. Alright, so the dot goes to, here's the box. Here's my box, y'all. I need y'all to tell me what to put in these boxes. What goes in the first box? Second box. What goes in the third box? What goes in the third box?
3 to the second power? Or just the exponent, 2?
All right, so let me ask you, let's go back to this one again, because y'all are looking at it like, what in the world? So the dot goes underneath here. You draw your arrow to this number. Whatever this number is, it's gotta, the whole thing, whatever this whole thing is, it's gotta be what goes in the third box. So what goes in the third box is gonna be 3 squared. Not just to the exponent. Are we pointing to the exponent here? Does this last arrow point to an exponent only?
I thought so. But I guess
No,
not.
because it's not. Look what we got here. We put in this box. We said put a 3 in the first box or 1 in the second box, and whatever's in this space right here goes in the third box.
But that one, it's like.
It's got 3 to the 2, but how much is 3 to the 2?
No.
It's a number, right? So can I just rewrite it as 3 to the 2 and not instead of writing it as 9?
Yes.
So I'm trying to make sure you're okay with this for a second. 3 goes in the first box. You are okay with the 2 going in the second box. You gotta put what's left in the third box. All of what's left.
How does that equal to the?
It don't equal?
No, because I'm confused.
Does 3 to the 2 equal 3 to the 2?
Yes. I'm just confused how because you said it's gotta put the whole thing. I don't know why I'm just thinking.
Because it's what's in this space. What's in this space right here. Whatever is in that space right there is the whole thing that's in that space has got to go in that box.
So what did you say about it's always gonna equal the exponent when you were describing log 3 to the square equals 2? How did you describe that?
Which up at the top up here?
The second, log 3?
Yeah, the one you
To the right.
To the right. Okay, right.
Right there at the top where you say log 3 and 3 to the second equals 2.
Okay, so what goes in the first box?
No, how did you describe it when you said it's always gonna equal? So if the 3 at the bottom and the 3 squared, you're saying it's always gonna equal itself?
These two numbers should always equal each. Whatever this value is should always equal that value. So for over here, does 3 to the 0 equal 1? So this value does equal that value. Does 3 to the 1 equal 3? That value does equal that value.
It's the 2 boxes that's confusing.
No, I understand
that's
that.
what it was.
I guess I was
She
thinking
was
when you
saying
were
the
saying
same.
log, the equation itself, log 3 second equals.
You're saying that should they look like this? So this one has to look like 3 with a 0? Okay, go ahead.
I always know that it's gonna equal 3 to the second power when I look at log 3 over.
I think she's
second
talking
power
about when you
equals
said
2.
if the base and the numbers are the same, the answer is the exponent.
Yes.
Right.
But that's just all, this is what you're gonna see in the homework. They're just gonna look for the number 2. So the answer is, what's log base 3 of 3 to the 2 power? The answer is 2. This was just me just showing you that it is true. This was just a check. The homework not gonna ask you to check it. The homework not gonna ask you to do none of that at all. It wants to know that answer right there. All I did was draw the circle to actually show you that I checked it. None of this is gonna be what you need to do. This was just me showing you how to check it, to make sure you got it right. So you don't need any of that at all.
It's confusing.
So what's the answer?
No, I guess I was, when you erased it, I was like, okay, but then I think when you was trying to check it, that's what confused me.
Right, the check part. I'm saying the check part is just me showing you that it does prove to be true, but the answer is just 2.
Okay.
So hear me put another one up here. Log base 5 of 5 to the 6th power. What's the answer?
5 to the 6th power.
5 to 5 to
I'm saying 5 to the 6th power.
This is log base 5 of 5 to the 6th power.
Oh, 6.
Okay, the answer is just the exponent.
Oh, that's
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 it.
what I was saying.
Okay, that's log base 15 or 15 to the 2 power. What's the answer? 2.
Oh, that's what I was. And they're gonna check it.
Now, if you want to check it, but you shouldn't need to check it because the answer's right there. I was just proving to you that it was correct.
Sometimes simple stuff is confusing.
I get that. I can get that.
Check it, it made me confused.
Gotcha. All right, don't check it then. Don't check it, y'all.
Don't check this one.
Just make sure you agree with what the property
Check the
says.
rest of them.
Huh?
We'll check the rest of them.
Okay.
Let me ask a quick question.
Yes.
That's what I was saying, so it's always gonna be 15, it won't be 15 base and 14 two.
These numbers have to be the same.
They-
In order for this property to work, both of these numbers gotta always be the same. Always, always, always. It changes the whole game if those numbers are not the same. Alrighty, so with that one said, let's see, now let's do bullet number 4, which gets even more interesting. This one says, B raised to the, what's the exponent in this particular problem? The whole log part is the exponent. This is a whole exponent, this log base b of x is the whole thing is the exponent. Now, they only want you to tell me what the answer is. What's the answer?
Log B of X.
So that I just gave you the answer. Look, the answer is x. That's it. Let me write it with numbers in it. So 3 to the log base 3 of 2. What's the answer? Hold on, don't say it yet. 2. Okay, 5 raised to the log base 5 of 4. What's the answer?
4.
Okay, 6 raised to the log of 6 base 7. 6 raised to the log base 6 of 7 is? The answer is part of the exponent. Remember, all of this is the whole entire exponent. This is 6 being raised to the log base 6 of 7. The whole thing is the exponent. This whole thing is the exponent, so you only want the number sitting right here. So you can't say I want the exponent, I want part of the exponent. One of the ways to say this, if you're working with log and 2 numbers are the same, the answer is the other number. You see what I'm saying? You got 2 numbers that's the same, the answer is the other number. You got 2 numbers that's the same, the answer is the other number. You got it?
Yeah.
You got 2 numbers that's the same. 5 and 5, the answer is the other number. 3 and 3, the answer is the other number. 15 and 15, the answer is the other number. Same thing over here. You got a 5 and a 5, the answer is the other number. So that's how that one always works. Always, always. So anytime you have a log equation written in this format and you got 2 numbers that are the same, always just pick the other number. And that will be your answer. All right, ready? I'm going to skip over the bullet in the middle there because it's going to be explained in the next one so we can see what we mean by that. Okay, can I erase the first board? Can I?
Yeah.
Okay. All right, I'll leave the original one up there. So I'm gonna work on the last 3 red bullets that you see on the board. Those are called properties that I want to say times. Here is log of m times n. Do you agree when you got 2 variables beside each other, it means times? So I'm gonna actually put a times sign in here so you don't get them confused. That's times. M and n, that's times. In this property, times turns into addition. Times turns to addition, so now this is log of m times, not times, what did I say times turn into? So log of m plus log of n. Let's use a real example. Here's a real example. Log of 6 times 3 is the same thing as what? Look at what it says you're supposed to do. Times turns to addition, but when I say addition, I'm just now going to put the sign for addition. So this is now gonna be a log of what? 6 plus log of what? Done.
It's gonna be written like that?
Oh, I see it. Okay.
Now, here's what the homework is gonna do.
There you go.
Watch what the homework is gonna do. The homework is gonna say, what's log of 18? And you gotta remember 18 is 6 times 3.
Oh, see, I knew it.
See, that's what I'm saying. You gotta, now, and it'll give you some numbers to work with. Like it's gonna say, given log of 6 is equal to this number, and given log of 3 is equal to this number, what's log of 18? And they're gonna expect you to be able to write it like this and simplify it from there. We'll do one from the homework so you can see for sure. Alrighty? So that was just property. I don't want you to be stuck on that. I want you, let's finish the properties. So that was property number 1. Multiplication turns to addition. Then guess what? Division turns to what? So now you've got log of m, subtract log of n. Let's put real numbers in here. So log of what? I'm gonna use the same numbers. Or actually, let me use the different. 4, not 4, but 5 divided by 4. The log of 5 divided by 4 is equal to the log of what? 5 subtract the log of 4. You okay? So division turns to subtraction.
What's the B for? It doesn't mean anything?
It's base. So that number will always stay right where it is. You don't do anything with it. Remember we said you got a base 3 right here? That little bitty B that you see on the board, it's always gonna stay right there. Don't do anything with that number. Leave it right where it is. If it's a letter, don't put it, put it as part of your answer, but I'm saying leave it right where it is. So if there's a B right here, leave it. Don't try to move it or add it to anything. Just leave it right where it is. So in the homework, it's gonna have a letter or a number there. Don't do anything but leave it in its place, right where it is. Don't try to add it to anything, just leave it right where it is. Okay? All right, here is the last bullet. The very last bullet says, if you have an exponent, log to be base B of 5 raised to the 4th power. What happens to the exponent? It gets pulled to the front. If you have an exponent, it gets pulled to the front of the word log. Do you see? The 4 got pulled to the front. Anytime you have an exponent, you can pull it to the front. You're just rewriting it. Those are the 3 basic properties. Okay, so addition turns to, the multiplication turns to, division turns to, and exponents get pulled to the front. Okay, now can you do this backwards?
Yes.
Yes. If I have given you some subtraction, what you gonna turn subtraction back into? If I give you some addition, what you gonna turn it back into? You got it? And if I give you a number that got pulled out front, what you gonna put it back as? These go both ways. So you can go backwards and forwards, and the homework is gonna ask you to do that.
Does the B or the exponent, does it go with the equation?
When you say B, you mean this little?
Yeah, the base, yeah.
Yeah, it goes, wherever you see it at, it should stay there for the whole entire problem.
Okay.
You just don't do anything with it, but let it sit where it is.
Okay.
Alrighty? Alright, now you're like, well, when will we ever use this in real life? In this particular case, not that you would ever use it, but, however, whenever they tell you that the earthquake measured a 6.5 on the Richter scale, logarithms is what was used, the software that's used to actually determine the intensity of an earthquake. So if you're going to be the earthquake chaser, what do they call them? Yeah, but no, what's the earthquake chaser called? They're not the seismologists. So people that actually do all the analysis of earthquakes, they're called seismologists. So if you're going to be a seismologist, then you would use this information. I have no desire to be an earthquake chaser. Okay, question.
Are these gonna be in the form of word?
You shouldn't have any earthquake questions in the homework. It just wanted you to know that it can be used in real life. And of course, this stuff is already built into the software, so it's not like this person sitting around doing logarithms by hand. They're not. Their software with this already built into it. Okay, questions? That's all of 5.2. I want to mildly introduce you to 5.3 just so you see what's coming. Just so you get to see what's coming. Now, equations. Solving exponential equations and log equations is the next section. I'm just going to do the first one so you'll get a chance to see what this is going to feel like. You're like, we don't want to see what it's going to feel like. All right. Solving equation. When you hear the word solve, what should you be doing? Solving and do what? What does solve really mean? Get X what? By itself. All right, that's the goal. So here's the first one. Then we're going to do this one and then we'll stop. All righty. Is that written in exponential form? To solve it, you're going to need to use logs. So let's do what they did. And I'm going to add some steps in that are not on the PowerPoint. So I've got 3,000 is equal to 150 times 10 to the what? 4t power. The goal is to get what by itself?
Why? I mean,
Whatever letter of the alphabet you see up there. So the goal is to get the variable t by itself. So I'm going to start doing things to get t by itself. First step, let me ask you a question. What's A, B, and K? Is this increasing or decreasing? Increasing because A, B, and K were all positive. So this is the increasing curve. We're good. So now the first step, I need for you to divide both sides by 150. The whole goal is to get t by itself, so I got to start getting rid of stuff. So I got to get rid of that 150. So divide both sides by 150. What's 3,000 divided by 150? Somebody tell me.
20.
20, okay? So if it has an A, because you told me A was how much? What was A? If it has an A, divide both sides by it. If it don't have one, you don't have to do step one. Alrighty? So step one was what? Divide both sides by what? By whatever A is. Divide by whatever A is. Whatever A is. You don't have one, you skip step one. Step two is whatever A is. Remember A, B, and K? What's A? 150. You're looking at me like, what in the world is A?
I thought it was.
No, this is the format of an exponential equation.
Oh, yeah.
That's A, B, and K.
That's right.
So if it has an A value, then you divide by whatever A is on both sides. If it doesn't, skip to the circle method.
I mean, that orange is like really.
It's hard to see.
It's gonna blind me even more.
All right, here's green. All righty, so that was whatever that said.
Thank you so much for your efforts.
All righty, so that's number one. Number two, circle method. You can't solve an exponential function without doing the circle method. So here's the circle method. Where do I put my dot?
And the T.
Put your dot underneath the T. So here is, I'm not the T, but on the side where the T is. Here's my circle. All right, this is the whole thing it's pointing to right there. Can you see it? All right, so log, what goes in the first box?
10.
Second box.
20.
Okay, so 10, 20 goes here. What goes in the last box?
4T.
4T. Now, will your calculator ever need you to put this 10? No, it automatically, the LOG that you see on your calculator, this is what it refers to, base 10. So I'm going to rewrite it without the 10. Okay, wait, I already put my, so here was a circle. Alrighty, that was a circle method. All right, how do I get t by itself? Divide both sides by 4. Alrighty. Then your calculator, log 20, divide, depending on your calculator, I will put this in parentheses. Log 20 is equal to what? And then divide that answer by 4.
Oh, so it's the whole thing over 4.
Uh-huh. And what's my answer? Somebody tell me. Log 20 divided by 4. 0 point what?
Hold up. 32526.
And the homework will tell you how many decimal places to round it to.
3. Oh.
It will say 3 or 4, or whatever it tells you to round it to. It will tell you what to round it to. Okay, so that's what you're going to be doing in 5.3. We'll finish 5.3 and 4 when you come back. All right, when is your test again?
That's 5.3 before we just.
Yeah, we just started 5.3.
Oh, we just started.
Oh, it's not the same thing?
We just started.
We just started 5.3. Solving exponential and log equations is 5.3. We just started it.
So my rule is 4, you know what that 4 and 2 is, you divide by.
Yep, whatever's left over here, whatever's left over here beside this T or X or whatever letter, you divide by it. All right.